Okay, hello everyone. So this presentation is titled Live Coding in Scala.js. My name is Haoyi. Who am I? I work at Dropbox writing Python during the day. So if anyone here is looking for a Python job or wants to come work at Dropbox, it's a cool place. You can come look me up after the presentation. On the side, I write Scala, and I have been writing using Scala.js since about last October. I don't do most of the core work on the compiler and the runtime. That is done by these two guys, Sebastian and Tobias. But I'm the one who sends in all the tickets when things break because I've been the one who's been pushing Scala.js most to its limits. So what is Scala.js? Scala.js is a Scala to JavaScript compiler. So you take in Scala code, you compile it to JavaScript, you dump it in Chrome, Chrome runs it, you have a website, you have a web game, you have whatever you want to build that works in the browser. And basically, the whole of Scala works. So there's a catch, there's a little star there to say that's not quite true, but I'll go into that in a moment. So basically, the transformation more or less looks like this, where you take in Scala code, that's what's shown on top, and you output JavaScript code, which is what's shown at the bottom. Can you see the mouse? Yes, you can see the mouse. So you can see that, for example, the main object becomes a main dollar class, which is kind of like what you see in Java. The method main becomes a prototype method over here. It takes in an array of strings with returns a void. All this is stuff to handle Java's method overloading. So this doesn't do anything. It just runs and exits. But I'll show you some stuff that actually does do something. So the first live demo tonight is called Scala.js Games. So this was the first set of projects I made using Scala.js. And it is a set of 6 games that are written in Scala. For example, here's asteroids. You can run around shooting things, and if you crash into something, you'll die. Let's see if we can crash into something. There you go, I died. You have snake. Well, so what's interesting about this is that all this is written using Scala. And if you look at what's inside the application, let's say no, I don't want to bring up the network panel. Don't want to apply. Let's say I reload this. You can see that the optimized blobs from all these games is, why isn't it telling me how big the blobs are from cache? Well, if I Control-Shift-R, it won't load from cache. Well, here you go. The games are about 300 kilobytes of JavaScript. So if you look at what's actually inside this, I'm not sure if you can see, it's minified by the Google Closure compiler, so it's not really readable. So this is what you can build using Scala.js. So back to the slides. So one question people ask is, like, why do you want Scala.js? Well, one question I would ask people here is that who here likes Scala? Does anyone here like Scala? I'm sure lots of people here like Scala because it's a Scala meetup. But who here likes JavaScript? OK, so there's some people with hands up, some people meh, some people don't really like it. And these are quotes I grabbed from the various Scala mailing lists. I can't remember who said which one, but I didn't interview anyone. These are things said spontaneously on the internet. And this basically sums it up completely. Like, people like Scala. People like writing programs in Scala. People sometimes hate writing programs in JavaScript for a bunch of reasons and prefer writing them in Scala. But when you're writing stuff in a browser, making a website, making a web game, making a web app like a Dropbox website or Facebook, you can't write it in Scala because Scala runs on a JVM, and you don't have a JVM in the browser. But if you can compile Scala to JavaScript, you can write Scala in the browser. And you no longer have to muck around with crazy things like the JavaScript inheritance model, JavaScript scoping, JavaScript's this scoping. All those things are solved if you just write the program in Scala, and the compiler will take care of all the craziness for you. So how does it work? Basically, you have a Scala compiler. It takes in a bunch of Scala files. It spits out a bunch of class files at the end. Scala.js is a compiler plugin. So it cuts in just about maybe 2/3 the way through the Scala compiler and takes a simplified Scala AST and turns into a bunch of JavaScript files instead of turning into Java bytecode. So these are then bundled into a few bigger JavaScript files, which then go through the Google Closure compiler, which is a JavaScript optimizer, kind of like ProGuard, but for JavaScript, which does a bunch of optimizations to turn into a few very small JavaScript files, which you can then include on the web page. So some more details. The class files aren't used. And the Google Closure compiler does a lot of actually very advanced and very aggressive optimizations, like dead code elimination, what's often called tree shaking, in order to remove all the unnecessary code from the program. So Scala.js was first announced last June at Scala Days by Sebastian. The hello world was about 16 megabytes of JavaScript. That is a lot of JavaScript to load on a page. Here's a demo he showed off. This is written using Scala. It is quite cute. I will show you, how does this work? Yeah, so that's reverse-y. I will show you some more demos later, which are also very cute. By August, we had it down to a smaller bundle of JavaScript. Still took a while to reload and recompile the application. By October, it was even smaller. I made the games that I showed you. Someone managed to compile Scala Z to JavaScript. Everything worked. The whole test suite passed. In November, I made Roll, which is another game which I'll show you in a moment. Probably one of the larger applications that have been made using Scala.js so far. And we're down to 400 kilobytes. December, we finally have a test suite. We have one small cross-platform game I can show you here. Let's see, where is the online demo? So this is a game that works both on JavaFX and on the browser, which is quite cool because that's the point of what Scala.js is for. So you can play with it. It's not that fun. It's kind of difficult. So next, where we are today. Now you can see the progress we've made from 16 megabytes is down to 300 kilobytes. The edit, compile, reload cycle is about 1 second, which is pretty nice. The whole of the Scala test suite passes, except for the things which are specifically Java, like threads or parallelism or system.exec. I have a bunch of cross-platform libraries which I made. One templating library, one change propagation library, one unit test library, and a to-do MVC example I'll show you later. So here's the next demo I'm going to show you. This is Roll, which is a game I made last November. It is also written in Scala. I'm not sure what you think about that. So this runs in the browser. This is hosted on GitHub pages. The goal is to take your ball, roll it left or right. You can draw things on the screen using your mouse, which will allow you to climb over things, for example. That's quite hard. OK, that doesn't let me get to the target. And the goal is naturally to get to the thing that's labeled goal, which is kind of obvious. And this whole thing's written in Scala. The first level is easy. The next levels are pretty difficult. There are a few levels so far, not a lot of them, but it's work in progress. But so what does it mean to be written in Scala? So the physics is using a JavaScript library. And if I go to, let's go to lihaoyi.github.i.roll. No, that's wrong. github.com lihaoyi.roll. So this is the source code of the project. So for example, if you look at the Scala code, let's say we want to look at where the clouds are implemented, because those clouds did not appear there on their own. I had to put them there, and I had to make them move. So the clouds were implemented here. This is clouds.scala. It is a class which does some things. For example, over here, it draws on the HTML5 canvas, drawing a bunch of cloud images, which are these SVG images, which I have in the folder. Every time you update, the clouds move. There is this little modulo sign. So when the clouds go too far to one side, they'll reappear on the other side. So all this is written in Scala, and I can show you the rest. For example, here are the lasers, which go forward until they hit something. And if you touch the lasers, you die. Here you are, see? So if the result of the lasers collision is the player's body, you kill the player. So this is basically the source code for this game for Roll. Sorry, go ahead.
What library you're writing to or calling to do the rendering on the canvas?
The standard DOM library. It is, I can show you. So the rendering on the canvas should happen, well, I actually did show you. The rendering on canvas is this guy, a canvas rendering context 2D, which is this canvas, I can't type, yeah, this guy. So I'm just literally calling draw image on this person. I think this guy has a draw image. No, his prototype has a draw image. Yeah.
That's the nice thing here. You're actually calling it JavaScript.
Yes, so it is a JavaScript library, and it is the JavaScript canvas library. I did not install it. I did not add it to a download. It is this function you see here in JavaScript, which I'm calling from Scala. Calling it from Scala looks like that, which is actually very nice. The this is what I call FFI, the foreign function interface. To call into JavaScript is very simple and easy to use. Apart from rendering, the physics is done with a physics library called Chipmunk.js. So for that, I had to write my own foreign function interface, which is basically a bunch of stubs. Let me get rid of this, of functions that you can use that each correspond to one Chipmunk.js JavaScript object or JavaScript class. So for example, I have the vector, the Chipmunk.js vector, Chipmunk.js BB stands for bounding box. I have the Chipmunk.js shapes. And now once I've defined these facades, I can use them really simply. Like for example, if I look here, which things on this piece of code are JavaScript objects and which ones are Scala objects? It's actually pretty hard to tell. So cp.vect is a JavaScript type. Scala, cp.space is a Chipmunk.js physics space, which is what they use for the physical simulation. The rest is mostly Scala dom.btoa. Some of you may remember that as a base64 translator is a JavaScript function, which is this one, btoa, yeah, this guy. So the graphics is just JavaScript graphics, drawing circles and shapes. The logic is mostly Scala. The physics is in JavaScript. So that's kind of the things you can do with Scala.js. This application is a few thousand lines of JavaScript, about 2,000 lines of Scala, and a few hundred lines of XML, which defines the level layout. So if you look at bundle, yeah, so these are the levels, each one written as XML file using Adobe Illustrator. So you draw them out in Illustrator and import them, and you have a piece of code which runs through and turns them into Chipmunk objects. So that's a bit too much detail for now. All of you look very lost. So back to the presentation. So the next thing is basically some live coding. So now I'm going to show you how to actually make a Scala.js application from scratch. So it's going to be quite intense, so you have to interrupt me if there are questions. And if someone could keep the time and interrupt me 20 minutes in, that would be great. Volunteers? Sure, well, you want to keep time for me. So I'm going to sit down because typing standing up is hard. So let's move the browser to one side. And let's look at what we have over here. This is a page which doesn't show anything because it's broken. And this is a Scala.js application over here. So this is one of the skeleton applications which I put on GitHub. So to use this application, let's see what branch I am in now. I'm currently in master. I tell SBT to package.js. So this will take a few moments. Package.js is what turns the huge mass of small JavaScript files into a small number of larger JavaScript files that you can open up in the browser without having a million script tags. Oh, well, there's nothing important down there or up there. So the top is just the item top bar. You don't know if you really want to see that. So you can see it's packaging a bunch of JavaScript into a few files. It's taking a while. But when it's done, which will happen any moment now, I will be able to open this in the browser and show you a simple example. Yep. Yes, you would. For jQuery, one is already written. For other libraries like Angular, you'd have to write your own. Like Chipmunk.js, I had to write my own. It's a few dozen lines of code. It's not terrible. Basically, every JavaScript class needs a corresponding Scala class, and every JavaScript method needs a corresponding Scala method, which has a question mark value. OK, so it's done packaging now. So let's see if I can open this up in the browser and see it work. So I don't know if any of you recognize this code, but this code is an algorithm that generates Sierpinski triangles. Basically, you start off with 3 corners of the grid, and every step, you pick a random corner, and you take your current position and move it to a point halfway between you and the random corner. And then you draw a spot there. In this case, I made the spots nicely colored. Sorry, over here. So now you get so in this way, you get a Sierpinski triangle. So some of you may notice this workbench thing. This is a handy tool I made that lets you do live reloading in the browser and lets you get SBT log spam in the browser, so you don't need to keep looking at a terminal. So enough talking. Let's say I want to make this white. Let's say I want to make this white. I do this, I save it, it's compiling, it's white, yay. What if I want the gray background? And what if I want to make it go really slowly? Let's say like that. Let it compile. Compile, now it's gray and it's really slow. Let's say I leave a typo in the program, what happens? Doesn't compile. So this is kind of what the experience of making stuff in Scala.js is like. And now I'm going to make a game for you. So I'm going to leave some of this scaffolding. Well, I don't really want this for loop anymore, so I'm just going to get rid of it. I do want to fill the canvas. Let's say I fill the canvas. First, I need a reference to a canvas. So this is a bunch of code that says document.getElement by ID. People already know what that is, I think, at least those who know JavaScript. Because the JavaScript DOM is untyped, I have to cast it to a HTML canvas element, which then has a getContext method. All these guys are statically typed because we have written the foreign function interface to all the common JavaScript functions in the most browsers. So you actually get quite a handy IntelliJ autocomplete in the editor. And again, because JavaScript is not typed, I have to cast into a canvas rendering context 2D before I can continue using it. So let's say instead of getting the rendering context directly, I get a canvas, which I then use to get the rendering context. So let's make this look pretty, let's make that look pretty. It's inconsistent, that's OK. Let's say I want to make the canvas black as a background. And let's say I want to get rid of this loop. It is not interesting. So let's let this reload a bit. What happened? Nothing happened. Why did nothing happen? Because I'm only filling the top. Because I'm only filling the top right corner of the canvas. Actually, no, because I'm not calling the clear method, which is what actually fills the canvas black. OK, so now the canvas is black. Let's say I want to make the canvas the height and width of the window. So I'm not sure how to get the height and width of the window. It might be this one, I'm not sure. So let's ask Google JavaScript, get height of viewport. So that's because I've clicked this before because I made games before. It's document.dom.document.documentElement.client height. And I guess width should be the same. Width. So, oops, there we go, fix. No, why is that wrong? Client width. Client width. OK, so now I'm done with Stack Overflow. I don't need him anymore. I'm still only filling the top left corner of the square of the canvas. Let's set the canvas once because I don't need to keep setting the height of the same width of the same object. And let's say I fill the rectangle to canvas.width. This comes first, and canvas.height. So yeah, now it's filled the whole thing. So now I have a black canvas. So question is, what do we want to make with the black canvas? And does anyone have any ideas what they want me to make with a black canvas? No one has?
A yellow triangle.
OK, yellow triangle. So let's see. To make a yellow triangle, I would say I need to use a JavaScript path things. So I need to do context.move to. Let's say I want to move to 100, 100. Context dot, let's say line to 200, 100. These numbers are pretty arbitrary. And after that, then you call context dot. See, so clever, it compiled, but it's still not doing anything. Let's say context dot fill. So what should this do? This should probably do nothing because it's still filling it as black. But if I then turn it to yellow, I now have a yellow triangle. Yay! So let's do something more interesting. Let's make the yellow triangle move around when I use a keyboard. So in order to make it move, let's get rid of these things that I used to need. I don't need anymore. Let's reuse this variable p I had. Let's call it player. Let's make the player live in the middle of the screen, or start in the middle of the screen. Oops, what am I doing? Canvas.height over 2. Why is it complaining? It's complaining because point is declared as int, but canvas.width is a number, which is a double because JavaScript numbers are double. So I'll just make this guy take doubles, and that should do the right thing. So compilation failed. Why did my compilation fail? Oh, this guy is missing. There we go. But this is not quite what I want, right? I want to make the yellow triangle be drawn where my player is. So let's say do that. That looks okay. It looks a bit strange. Let's say I want keyboard input. DOM dot add event listener. I guess let's use on key down. So equals what is DOM dot on key down? Well, it's an event handler for the property for keyboard down events. It takes a function one keyboard event to any. So let's say I take E, which is a keyboard event. Let's call it DOM.keyboard event, just so it's easy to see. It's a JavaScript thing that I'm talking about here. So it's complaining for some strange reason. I need to do. So it's complaining because it's using an old version of the library. So if I update this to the new version of the library, it will stop complaining. So let's tell it to do that, and it should stop complaining. Wrong. I need to tell IntelliJ to take note of it too. So I don't know how many of you use it. The SVT IntelliJ plugin is great. So this will take a moment while it's, no, I don't need the dictionary. While it's cleaning up and looking at the project and packaging everything. So now it's done packaging for IntelliJ. Let's go back here. Okay, yep, see, so stop complaining. The compilation's not quite done, but that's okay. So what do I do on key down? Let's say I want to pop up an alert box. Alert 10, nope, doesn't work. And you say dom.alert10 because the global JavaScript namespace for here is called DOM. And why is it complaining now? Oh, because I need to do something like this to make it happy. OK, so if I key down, yay, 10. More annoying than useful. So let's say I want to keep track of which keys are down so I can move my character around. Let's say val keys down equals collection.mutable. What do I want? I probably want to set, because I want the keys which are currently down. Empty, let's say int. So keys down dot e dot key code dot to int, because it's a double, equals. Yeah?
HTML local storage?
I can use HTML local storage. So I can't remember what the API is for HTML local storage, but I'm quite sure I've written the FFI. I have written them. Yes, you have to, and I have already written them, I believe. So how do I do it? I need to get the session storage. So in theory, if I say dom.session storage autocomplete, there we go. Yeah. So it will work. It will translate to what you expect. So where was my example? My example was here. So it's a set, so I should add it. On key up, I should remove it. Let's refresh this because it appears to have gone to a weird state. OK, so that still should not do anything. If I dom.console.log keys down, I need to tell it to make it a string because otherwise because it asks for a string. So 37 is left, 39 is right, 38, 30, 40. So that's how user input works. So if I say if dom dot, I don't want dom, I'm going to say if keys down, what was it, 37. Not sure, oh, it's compilation error. Player.x equals player.x plus point, that's what it's called? Point. Left should be negative, let's say -1, 0. So that's 37. 39s would be +1. And I think 40 and 38 were the other two. So 38, 40, 0, 0, -1, 1. Yes, nope. Why is it complaining? Yes, you're right. So I should actually not be trying to assign a new value text. I should be assigning a whole new point. At least the way I define point, it's immutable, and I need a whole new one. OK, so here I am. And you can see it's moving very slowly. Let's make it go a bit faster, because this is pretty slow. Let's increase the frame rate to once every 20 milliseconds instead of once every 50 milliseconds. Here we are. That's probably not what you want in a game, but you could do this, in which case, let's say I make one of them 100, one of them minus 100. Let's make it 10. And let's say 10 plus 10, let's say, OK. Here we are. Why is it not clearing? That's a good question. Let's see why it's not clearing. In theory, it should be calling clear and filling the whole rectangle with black. Let's see if it actually is calling clear. Yep, so it is calling clear. I'm probably misusing the DOM JavaScript context draw polygon. I'm probably misusing this somehow. I think it's making my polygon larger and larger, and I need to call, here we are, context.begin path. There we are. So now we have a thing that can move around. So let's take a short break from the live coding and take a look at what's being done in the back end. So if you look at the Workbench example app, it's a normal SBT project. Let's look at the project first. It has the Scala.js plugin. It has this Workbench plugin, which I'm using, which is what gives me the log spam in the browser here, as well as the live reloading whenever the code changes. It has a build SBT file. This is a poorly named settings from the Workbench plugin, which I'm using. These are the statically typed DOM facade or FFI classes, which I showed you earlier for Chipmunk. If we want, we can look at them. Scala.js DOM. So they are these guys. And what they do is that they give you static types for all the various things they could want to do on your in the browser on the HTML DOM. So if you're wondering where, for example, if you're wondering where alert came from, that probably should be somewhere in here. So def alert. So this is a foreign function interface facade, which lets us call the JavaScript alert function with a type-safe wrapper and with nice things like autocomplete in IntelliJ. So that's what the project looks like. And we look at the compiled code. So in here, you see a bunch of class files. Like I told you earlier, the Scala.js plugin doesn't actually stop the class files from being generated. But what it also does is it generates a bunch of JavaScript files. For example, let's open this guy up in Sublime Text. So this is the point class I showed you earlier. You can see there's a whole bunch of rubbish we don't care about because it's a case class. So it has things like the product arity and product prefix and all that spam. A few more things. I probably won't go into them. They're not that interesting. Over here, they get packaged into a few big bundles. So example.js is all the JavaScript files from this project concatenated together. So the point class, the Scala.js example class, Scala.js example $point $, for the companion object of the point class. Internal dependencies is for subprojects. This one has no subprojects. External dependencies is for external project dependencies. So this includes the things such as our nice Scala standard library, which is what makes the external dependencies JavaScript thing 23 megabytes of JavaScript. So if Sublime Text is nice enough to let me open this, I think it's not going to. Let's open it here. Vim target, Scala 2.10, example, external dependencies of JavaScript. Sorry, I don't have syntax highlighting here turned on. But we just leaf through. You can see things like what's interesting here. I don't know what's interesting in our collections library. What? Yeah, here's the Scala implementation of class tags, compiled JavaScript, class manifests. Let's see if we can find anything useful. Scala.concurrent.duration, that's a new thing in Scala 2.10. Here it is all compiled to JavaScript. You can see the code is extremely ugly and long, but it gets compiled down to by Google, it gets compressed by the Google Closure compiler, which is why in the end the game is only a few hundred kilobytes, while here it's 23 megabytes. So that's more or less what the code looks like. Let's go look back at our example again. And let's say we want to see the code for here, let's say. So this is a mix of some Scala function calls, some JavaScript function calls, a JavaScript assignment, and some Scala operations. So I'm going to open it in IntelliJ just because that'll make things easier for me. So let's move this over and take this. This guy is in what? Scala.js example. So the Scala.js example $JavaScript file. And let's just let's just compare it. So this code here compiles down to this code here. So again, you can see it's extremely verbose and kind of hard to read. But it basically tells you exactly what it does. So here I call a method called clear, which has a return type of void. Again, I have to put the return type in the method signature, in the methods, just because in Java it's part of the signature. It calls a bunch of methods on the canvas rendering context 2D. The reason it's using strings to call them is the implementation detail, because that allows it to not get renamed by the Google Closure compiler, which does variable renaming. Over here is a bunch of if statements, which correspond to the if statements here. Addition corresponds to this addition here. You can see it's kind of ugly because this addition is not really addition. It's actually a function call with the $+ name, which some of you may already know from what it's like in Java. So this is basically how the code transformation looks. So let's go back to the game. What? Yep, so now it's 20 minutes. OK, cool. So I'll keep going with the application for another 10, 15 minutes, just because, so I give you a chance to look at what it's like working with this guy. Yeah, we have plenty of time. I have the whole hour anyway. So let's say I want to make this guy shoot things. Well, how do I make it shoot things? I need a way to represent the things I'm shooting. So let's keep the things I'm shooting as a list. Let's call them shots equals list.empty of point. So it's going to be a variable of an immutable list. Let's say I want to shoot when I press spacebar. I need to figure out how to make what spacebar is. So let's just print out what these key codes are, and I'm going to press spacebar after it reloads. Oops, I forgot to tell it to reload. I don't need to clean now because it's compiled with the right stuff. So let's let SBT churn away a bit. And OK, compiled, ready to go. Over here it says it's connected. So actually, no, it's not connected. Well, it will be soon. Yeah?
Give an example, rather than use like jQuery and JXCT, just doing it using features in Scala and do things such as, go and fetch a video clip.
OK, sure. So let's dump this game then, because I guess you guys already know how it's going to work. And let's open up another project I have. No, but it's OK. So let's open up. So I don't have any example that uses futures, but I can show you an example using normal Ajax.
Well, that's the thing. I want to think in Scala. I don't want to think in jQuery.
OK, so let's move to Scala. I have a bunch of branches here, some of which contain interesting things. So please commit your changes. Let's kill everything.
Just so that you understand, where that becomes interesting is this is actually based on JVM construct.
Yep.
And now we don't have that underneath.
Yep.
How do we handle it? We
Sure.
You know, the underlying machinery. That's
Sure.
kind of my plan.
So I'm gonna show you a project which uses 3 libraries which I have, which cross-compile from the JVM to JavaScript and run on both. So if you give me a moment to let SVT package it, I'm just going to show you what they are on the website. So kill this guy. Let's see. So one of them is, some of you may have seen this stuff before. One of them is Scala.rx, which is a change propagation / functional reactive programming library, which lets you do interesting things. I'll show you in a moment. Basically, this is what it does. It allows you to define smart variables, which depend on other variables. In this case, C depends on A and B. And when A or B change, the value of C will change automatically. So that's it is reactive is overloaded to mean a million different things. So it is unrelated to Java RX. I just use RX because I thought RX made a nice variable name, which it does. And it means the correct thing, and it's concise. Another project this uses is my HTML templating library, Scala tags, which generates HTML in both JavaScript and JVM. So now that this project is done reloading, let's take a look at how it works. So if I go back to the same thing, let it load. The first load is always really slow because it has to load the whole 20 megabytes of JavaScript. Subsequent loads become fast because the big one becomes cached. So this is a to-do MVC example that's written using Scala RX and Scala tags for the templating. So let me tell SVT to cooperate with IntelliJ. Then I'll have nice things in the editor. So the point of this is that I can use these functions and these objects, which are originally designed to run server-side on the JVM. And now I can use them running client-side in Scala, including things like futures and change propagation and execution contexts. So now that this guy is done, this guy should tell me it's time to reload. So here we are. This guy didn't want to reload properly. Let's say I refresh it manually. So what's interesting, this guy is implementation of to-do MVC. Some of you may have heard of it. It's a so-called standard web application which people can implement in different libraries or languages in order to gauge what the code looks like in that language or using that library. So one thing that's interesting about this is that the Scala implementation is 130 lines of code. Backbone.js is about 440. Angular.js is about 240. This is from the GitHub examples. And Google Web Toolkit is 950, spread over 14 different files. Whereas this is 100-something lines of code, one file. Live reloading works. Let's say I don't like the starting names of the tasks. Let's say I want to make them all start undone, and I want to make them lowercase. So let's see that happen. So lowercase, lowercase, lowercase. There we go. So what's interesting about this is also that I can do things like automatically. So what I'm doing here, I basically define a huge blob of HTML using the Scala tags DSL. Even though many of you have not seen Scala tags before, I'm sure you can understand what's going on. This is a section. Its ID is to-do app. This is a header. Its ID is header. Not very useful. But for example, let's say I want to add a new filter to this list of filters down here. I can simply add a new filter that says, what do I want this new filter to be called? All caps. I wanted to only show tasks which are all caps. So I want to filter out the tasks whose text, because text is a so-called smart variable, I have to say .now. Let's see, capitalize, there we go. So task, So this is a filter which should filter out things, only the tasks who have all caps letters in the definition. There you go, all caps. So that did not work. Interesting question is why did that not work? So let's do some debugging. Let's print out the different things that are being considered here, and then we can see why that is not working. So capitalize is not working. That's rather unfortunate. I think that's, what? Oh, should be title case? Yeah, let's do that. So map to, this guy should be a character, right? Come on, tell me. OK, it doesn't want to tell me what it is. But I'm quite sure it's a character. To upper dot. Do I need make string at the end? I can't remember if I need make string at the end. Let's see if this works. There we go. There we go. So I guess the implementation of capitalize is buggy. That's unfortunate. I shall fix it. But I guess this kind of also gives you the impression of what it's like to debug things in this system. Is it? Shouldn't that be title case? I'm quite sure it should be title case. Anyway, we'll figure it out later. So what's interesting about this is also that you can, is that under the hood, if you look at the definition of this guy, definition of this guy, and you see what's happening, let's say you go look how the change propagates through from smart variables to other smart variables. This is not very helpful because this is just an interface. Let's go to implementations. You can see that you can use futures, and it works perfectly fine. Future.sequence. All this is probably more complicated than you need to understand. But I guess the point here is that you can do all this complicated stuff and compile it all to JavaScript, and it will work. Like if this works, if Scala Z works, most of the things that you guys will want to do that's not particularly dependent on the JVM will continue working. So let's. So this is basically what I was going to show you later, but I guess you can see it now. If you want to see the implementation of the equivalent thing in Google Web Toolkit, it comprises com.todo.client. A bunch of files, so not 14 files. Well, if you include all the XML files, it's about 14 files. With some XML with a bunch of Java classes, which add up to somewhat more than 100 lines of code in total. Yeah. So that's one example. So let me go back to the presentation one moment. So I guess now you guys have seen how it's like writing code using Scala.js, using the IDE, how the live reloading is pretty damn awesome. I don't know if you made games in any other way. But so what did we use just now? We used Scala.js. We used Scala.js Workbench, which is the live reloading and SVT log in the browser plugin I made. Scala.js DOM is, as you said, you need to wrap all the DOM elements in static types, facades. I sat down for one afternoon. I just typed them all out and cleaned it up later and copied and pasted all the documentation from MDN, so I have nice doc strings. The project skeleton is here on GitHub if any of you want to take a look. These are some other games I made while rehearsing for this. This is a Dodge the Dot game. It's also quite cute. Oh, I died. This is a Space Invader game. So these are also made as preparations so I could live code this. So different games, but also somewhat related. And again, if you look at how big these games are, Control-Shift-R from cache. No, don't cache it. Here it is. It's not too big, 230 kilobytes and 64 kilobytes gzipped. So that's pretty reasonable. So future plans and ideas. We have lots of stuff that we'd like to do with Scala.js that we have not had time or the manpower to do. It's basically a volunteer effort with 2.5 people, with a bunch of volunteers, including me, making up the last half person, since there are only 2 people working on it full time. I can show you some of the cool things, like the Reactive UI library. Yeah?
So what is it you can't do? Like Clojure.js actually has only a subset.
Yes.
What is the thing that stay away from?
If you write it in Scala.js, it will be compiled to the correct subset of Clojure. So you do not need to worry about Clojure.js, about Clojure, the Google Clojure compiler. No, so there are 2 things here that we can talk about. One is some subset of Scala does not work because it's JVM dependent. Another thing is some set of JavaScript does not work because the Google Clojure compiler, which optimizes the JavaScript, will break it because of its aggressive optimizations. So in terms of Google Clojure compiler, you do not need to worry about anything because the Scala.js compiler will only output code in a very verbose format the Google Clojure compiler understands. So you saw that terribly verbose thing I showed you earlier. That's just because that's what we need to make Google Clojure happy. The other thing is subset of language that does not work. Let me show you that now. So let's say I bring back this guy. Reload. OK, so he's back. So let's say I try to do thread.sleep. This should blow up in theory. There. OK, no sleep method. So because we stubbed out thread for some other reasons, but thread.sleep does not make sense in JavaScript, so it blows up. What else does not work? Arca actors do not work because you rely on threads and other things. But there are some interesting ideas of what we can do ignoring Arca actors. So here's something that also does not work properly. On a JVM, this will blow up with a number, what's it called? Arithmetic exception, divide by 0. On JavaScript, it prints out 0 because JavaScript math is broken. But trying to wrap the broken JavaScript math to be not broken involves a lot of overhead because you need to keep checking whether it or not it did something stupid. So we decided that OK, maybe it's OK. If you look at Scala.js GitHub, there is an issue tracking this which says number integer divide by 0 does not blow up. Well, yeah, so we haven't figured out a very good solution for this yet, but we are still working on it. What else does not work? Array index out of bounds don't get thrown. So here's an array with 3 elements. I'm going to get a 10th element. And it's going to say it's OK. It's going to print undefined or something stupid like that. There we go, undefined.
Yeah, so it's not breaking the way JavaScript is breaking. That's not a problem.
But
where does it break where it shouldn't?
It doesn't break where the JavaScript would break, but it does break where Java would break, like here, or where JVM Scala would break.
Oh, you wanted to show us your future plans, like the
I have some. I'm just going to go back to the presentation for now, just to hurry up because I need to finish this, and then in Q&A you have more time. So this guy I've already showed you. This is a to-do MVC app. It's kind of like amalgamate. It's kind of like the same idea as React.js or as Backbone.js, except implemented in Scala. This is an optimized version of the one I showed you just now was under development, so it has a 20 megabyte blob. Once it's optimized, it is from cache. No. Once it's optimized, it's a 400 kilobyte blob. Still pretty big, but not terrible anymore. It's reasonable. I think I look at Dropbox, the website's blob of JavaScript is somewhere around 1 to 2 megabytes. So 400 kilobytes is painful, but not impossible. Other cool things you want to do. So this is what I mentioned early because you asked. We are pretty small. It's pretty small writing this stuff in Scala using Scala RX and Scala tags. And it works on the server too, which is cool, compared to many of the other libraries, which are pure JavaScript and much more verbose. These are all taken from the To-Do MVC GitHub project, if you want to go take a look. I did not write all of them. Yeah, so this uses the 3 libraries I mentioned earlier. Other ideas, play framework integration. Like this is not done yet. This is just brainstorming. What if you could just wrap a function in an Ajax function, Ajax call literally, and have it be automatically serialized and sent to a remote website? And what if your Ajax calls are all type checked? Like that would be super cool. Like at work, one of the most fragile things you do are the Ajax calls because they're all stringly typed. There's a ton of serialization to JSON, deserialization to JSON. someone decides to make it a CSV instead of JSON, comma delimited. Everything's very fragile. What if it was type checked? That would be cool. A web console. Here's another demo to show you. It is under development, so it's going to take a while to load because it is under development. So this is what I'm calling Scala.js Fiddle, which is an online REPL in which does exactly what I showed you earlier, except online without IntelliJ. So this is the same example as I started with. Let's say I want to change the color so they all filter white. I simply say white, Command Enter. It does the right thing. What if I want to take some of the games I showed you earlier? So where were my games? They were somewhere here. Workbench example app. There we go. So let's say I take the dodge the dots game. That's not what I wanted. I want the source code. So the source code is in the dodge the dots branch, source, main, Scala example, Scala example. I copy the whole thing. I leave off the package because this is a work in progress and does not support packages right now. I have too many tabs. Here we are. So I just paste this here, Command Enter, wait a moment. And there you go. It's a game. The math is wrong because the game assumes it's running full screen, and now it's not running full screen, so the math is borked. But this kind of shows you what's possible using Scala.js. Let's see what other things I have to show. Space Invaders. So just now I was in, I'm losing myself. Let's say I go to the Space Invaders branch, which is here. Source, main, Scala example, Scala example. Again, I just copy the whole thing. Where was it? Paste it here, bang. Let's go. Compile, compile, compile. Space Invaders. I'm not sure why it's still tracking my cursor. That's probably a bug. But yeah, so this is work in progress. But I guess you guys kind of see where the promise is and why I'm excited about this, because I think this is honestly really cool. And this is one guy's worth of work part-time. Like, I do have a job, so I work on this a small number of hours a week. So the example I showed you, this fellow, is 250 lines of code, client and server. So it's actually a pretty small project all in all. And with more effort, I think we can actually get a lot done with it. But for now, it's still very nascent. So let's go to the end of the slideshow just because. So these are takeaways. I think after seeing this, most of you should agree with this, with everything that's been said here. I honestly think there's a ton of potential here. Like many of the other compiled to JavaScript languages have a lot more manpower than 2.5 people and have not made as much progress in the same short amount of time. And I think many of you prefer writing Scala over writing Kotlin or TypeScript or CoffeeScript. And the ecosystem support is really incredible. Like being able to get static types in the IDE when writing Scala for the browser and getting instant reload, on almost instant reload when you make changes, is really powerful. Like that's something I don't even get when I'm writing raw JavaScript because I need to refresh the page to get it to work. Whereas this is really something else. So how to get involved? If anyone wants to try it out, it's on the internet. It's over here. It's GitHub Scala.js. The mailing list is Google Groups Forum Scala.js. There are a bunch of issues I showed you earlier. There's cool stuff you can make. And that is it. Cool. Yeah?
I get a question. So basically, I think a lot of Scala people are familiar with all the frameworks in JavaScript. And
yep.
It seems like there's some really rapid change in JavaScript world. So recently, David Nolan, who's a Clojure script guy, he wrote the OM, which is a binding to Facebook React.
Yep.
And he wrote a couple of blog posts where he basically says, like, each of these frameworks says everything else is wrong, and this is how we should do it now. And it's 10 times faster. So basically, he's saying that React is it's based on some immutable ideas, right? That you essentially detect what didn't change. So from the reading of this, it sounds like that's the right way to do it. So what's kind of your look at it? What's your opinion? So you're based on some underlying JavaScript libraries.
Well,
Do you need to know, for instance, what React is doing? If it's indeed 10 times faster, would you rather try to use your Scala bindings to base on what React JS is doing, or like, do you have to track this underneath JavaScript things and kind of bind to the latest and greatest?
if you want to, like that's the long and short of it. If you want to, you can. It will be work to write wrappers for all the libraries you want to wrap. So currently we only have jQuery and the native DOM. And I have wrappers for Chipmunk.js. You guys may not have heard of it before, which is the physics library I was showing you earlier, which powers the game I was showing you earlier. In terms of what I think is the equivalent of React is Scala.rx, which is what powered the to-do MVC example I showed you earlier. This would be much easier with diagrams, which I have here. I guess I don't need this guy anymore. So the idea is that when something changes, you only propagate the changes to guys who care about it, and the guys who don't care, like for example, B, doesn't need to even know. So it's a slightly different model. It's push-based rather than pull-based. Instead of diffing the two completely different, instead of diffing two large data structures, I am now pushing changes through the big data structure without touching the whole thing. So again, these are some more examples of basically how it works. And it works this is what I was using in Scala.js just now. I've used it on the Scala JVM a few years ago. It works great.
So we actually choose to bind to, let's say, D3, for
Yep.
example. How do you bind it to a specific version? Because, you know, D3 will keep on evolving, or AngularJS will keep
Yeah.
evolving. And whatever wrapper that you wrote, you want to be able to kind of fix it on a specific one, otherwise it will just blow up.
Currently, there are no checks. So it will just blow up. So if you forget to include D3 on the page and you try to bind it, it will blow up. So for example, this guy includes the DOM, the statically typed wrappers for the jQuery library. But I have forgotten to include jQuery on the page. So if I try to call jQuery.something, it'll just fail with the error. Like no such method found. So the reason for this is because Scala.js is about 6 months old. So things like backwards compatibility and stable versions are still a work in progress. So, yep.
Is there any way to like auto-generate these bindings, or have you guys looked at that?
Auto-generating the bindings in general is unsolvable simply because the JavaScript people do such crazy things with their APIs. I don't know if you think so. I certainly think so. There have been some attempts to auto-generate them from TypeScript bindings because a large number of those exist. Currently, no one is working on it. That is actually what I use to auto-generate the DOM, the wrappings for DOM. It's like 5,000 lines of code. I didn't type them all myself. I auto-generated them and fixed them up when necessary. But so it works. It's very cool. We have no one to work on it, so it's just sitting there. Yeah.
So you guys aren't implementing any of the Java standard library, right? So if my Scala code is depending on anything from like actual Java, I'm going to have to rewrite that.
Yes, and we have a small amount already rewritten. So we basically rewrote the things we found we needed. We're not going to rewrite like everything, but we have these fellows, we have these guys, all rewritten in Scala. So for example, longs are interesting because JavaScript has no long, so to re-implement long in Scala, like how Google Closure does it. Yeah, so if you want to reuse, for example, ASM, the Java bytecode library, you're going to have to rewrite it in Scala. But if you want to use a standard library, at least the parts that we happen to have needed so far, then it's fine. Yeah. Oh.
Kind of, maybe it's a wacky idea, but I'm going to write my stuff and I actually want to play within the ecosystem of JavaScript, like within being able to be loaded by NPM as for server-side code. Because, you know,
yes.
I don't want to write it in JavaScript, and I want to cooperate with others that write things in JavaScript.
You want to make a Node module with Scala.js? So you want to make a Node.js module using Scala.js? It has been done once as a proof of concept, and no one really followed up with it. But if you would like to pick up the project It is over here, a Node.js module in Scala.js. And as in, it's been done before. Like, it's here. If you want, you can clone it, test, and it'll work. But none of us are running on Node. I guess people don't see the value of running on Node.js when you can just run on the JVM when you're on a server. Whereas people do see value running in the browser. Yeah.
How is the Scala.js compiler?
It is implemented as a compiler plugin. Do you know anything about how the Scala compiler is implemented? So the Scala compiler is a bunch of code that is written in Scala and takes in, parses things, does type checking, all that. Multiple phases, gradually turning Scala into something that looks like Java and finally into Java bytecode. And the Scala.js compiler is a plugin that hooks in just after what's called a mix-in phase. So the mix-in phase is a phase after traits are turned into classes and forwarder methods. And it all lives in this folder here on the GitHub repo. And it is not a lot of code. It's few thousand lines. I think it's about 15, 20,000 lines of code that takes in the Java-like AST that hasn't been turned into bytecode yet and instead turns it into JavaScript. And it still goes to bytecode. So that's why IntelliJ can give me sensible autocomplete and type check and code highlighting, because there is the Java bytecode version of the code. It's just that for all the code that ends in question mark, question mark, question mark, if you run it on Java, it will blow up because the question mark, question mark, question mark will blow up. Yeah.
When you showed us the compiler output, there were source map files. Are those generated by the Clojure compiler or by the Scala.js compiler?
The source map files are generated by a Scala.js compiler. So
To hook up Chrome.
let me show you. Let's see, is this guy still running? That guy's still running. Raise, well, I think this should work. Source maps. Well, that didn't work. Oops. But well, this works. Scala.js example, lines 12. That's here. Well, that's somewhere here. Looks like it's wrong in this case. Yeah. So we generate source maps. They work in development for as source maps for the huge library we have, huge JavaScript blob we create. When Google Clojure compiler optimizes it down to smaller JavaScript blob, it also does a similar translation for a source map, so source maps also work. But yeah, so Scala exceptions, stack traces in the browser is pretty cool. Yeah.
So I wonder, so we have Adrian in the house. I wonder, like, is there anything Scala compiler can make better to make this thing easier?
Yeah.
And, like, what are sort of, from your experience, I mean, Scala is improving itself,
Yeah.
right? Scala is simplifying. Like, what features of Scala are the worst for this translation?
You're welcome.
I guess we've talked about on the mailing list. I think Sebastian has made more noise than I have about the Scala compiler because he's at EPFL.
So in 2.10 we wrote the pattern matcher, partly keeping this in mind to
Yeah.
less insane code.
Yeah. One thing that has helped a lot is that will help a lot is what's it called? Single assignment, single abstract method interfaces. So in the other example I had, I needed to explicitly type check the :keyboard event in the event listener, because the Scala compiler in 2.10 is smart enough to automatically fill that in if the function is expecting a Scala.function type, but it's not clever enough if it is expecting something which implicitly converts to a Scala function type. So our JS.function is subtly different from Scala.function in that it represents an unboxed JavaScript function, bracket, 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 bracket. Like, it represents a JavaScript function. So that would not type check unless I put the annotation to force the implicit conversion to work. But in 2.11, M8, or M7, which I've used, it works great. I'm not sure what else could be helpful. I guess a lot of the things would be helpful is throwing away what we do for Java. Like for example, specialization is a pure waste in JavaScript because JavaScript does not have the Java type system and it requires you to duplicate your code 10 times in order to make it unboxed. But because that happens earlier in the compiler pipeline than we hook in, we end up just having 10 different versions of for example, Scala.function, which all do the same thing in JavaScript, because in JavaScript there's no type system. So I'm not sure what else there is, but that's a few of the things that would help.
So should we use 2.11 for this?
It depends how cutting edge you're willing to live. Yeah, like you are using a alpha version, relying on the pre-alpha version of the Scala compiler, and you may have to make your own change with libraries which are 0 point something, which are compiled to the alpha version to Scala.js. So if you're willing to to fix all your own bugs when you crop into issues, when issues crop up, and you're willing to compile everything from source, if I haven't compiled it from source yet for you and put it on Maven Central, you have to compile it yourself, then sure, you can use 2.11 to do it. It has some nice things, like 2.11 standard library is much smaller. Since they have 24 megabytes, it's down to like 15 megabytes for an unoptimized version. Yeah.
What do you use it for your games?
Good question. Let's take a look. I think I started off on 2.10, and at some point I moved to, well, I don't know, I'm doing it in here. Nope, it's still 2.10, I guess. Yeah, I've experimented with 2.11, but it's still pretty rough. Like the Scala.js itself only released a 2.11 M8 version this morning. So you literally run the cases where, yes, it can be done, no, it will be done tomorrow, please wait, which is something you won't do in working with stable software, but here things are changing so quickly that it happens. Yeah.
Anybody started using Scala.js Akka?
So Sebastian has a proof of concept with Scala, what's called Scala.js actors. It is still very rough. It kind of works, but I personally don't feel confident using it, and it's